So in the last video, we saw how Scratch can draw polygons, and we can use those polygons to create some really intricate, interesting patterns. We're calling it algorithmic art because we're creating all of these shapes and patterns with code, with algorithms, recipes, if you like, using the blocks in Scratch to tell Scratch to draw and move and turn and draw and slowly but surely build up these complex patterns. Now, I told you there's a formula to work out the number of degrees. Remember, degrees is how far we've turned. So everybody here, I'm sure, knows what a clock is, right? If you imagine a clock, and around the clock are all of these divisions that are minutes. So if we just think about the minute hand, there's 60 minutes, 60 individual places that this minute hand could be at. And so, let's see if I can do this, yep. So here is 12. And if we move from there and end up being here, we can see that we've gone 15 minutes. Those of you that can read the time on a watch or a clock like this. So we've turned that much. Now, with maths, I want you to imagine we've got 360 of these little bits. And really what we're looking at is just a ruler that's been bent up into a circle. Okay, so it's been twisted around from this straight line into a bend into a perfect circle. Let me just get rid of this quickly. Okay, so we call those degrees. Degrees. And we draw it with a tiny little circle on like this. Degrees. Now, what we can do here is use this formula where we've got 360, that's our magic number today, and we divide by the number of sides. So we saw that with 4 sides, I'm going to put degrees there, we end up with 90 degrees. Now those of you that know your 4 times table will notice that 36 divided by 4 gives 9. If we just take off the zeros for a minute, we've got 36 divided by 4 is 9, or 9 times 4 is 36. Okay, there's a little trick we can use by taking off those zeros sometimes. It makes it very, very useful for us. So let's go back in here. 360 is our magic number. Now we can do this on a calculator. You can do this just in a browser tab. If you Google 360 divided by 4, it will tell you it's 90. But let's say our pentagon, let's test it, see if this was right. So our pentagon was a 5-sided shape. So 360 divided by 5, let's put our divided signs on there, is 72. That's how I knew. And our 3-sided shape, let's do 3 up here. So 360 divided by 3 equals, 120. So that means if we want to know a 9-sided shape, a nonagon, all we do is 360 divided by 9. Which should give us 40. If our reverse logic's the same, I'm pretty sure that's right. Okay, so 9-sided shape, we put 40 degrees in the Scratch box. Let's just jump back into Scratch very quickly, and we're going to test this out. So I'm going to type 40 in here and 9 in here and see if my maths is as good as it used to be. Let's see. So we've got 9 sides coming through. Oh, what happened here? All right, we're going to test that again. Doesn't seem to be right. I'm going to make my sides slightly smaller too, because sometimes we hit the edge and that doesn't work out right. So let's make this 50 steps. Let's try it. 4. Whew! Phew, thank goodness for that. So there we've got our nonagon, okay? And each of these turns is 90 degrees. I'll show you one more time what I mean about the external angles. I'm just going to grab a new sheet here, look. So Scratch is walking along in this direction, okay? There's an arrow. Now, to get the next turn, which might need to be like this, we're not measuring the inside angle, which we often do in maths. We're actually measuring the outside angle here. So Scratch has to now turn, not all the way around, but to be able to face in this direction. Now Scratch is looking down here, and if we want to turn like this, say we're drawing some kind of hexagonish thing, this is the amount of turning that we're doing. So we can imagine that there's little lines like that representing the degrees. Again, if that makes sense to you, that's great. If it doesn't, don't worry about it too much. So you always have to imagine Scratch is looking out the way that he was drawing, and then it's here how much we turn to be able to draw the next line across here.